Okay, the next part is RFE, recursive feature elimination, and we have already seen that once. So the process of the RFE is we have a machine learning model, and then originally we send all the features, the full data set into the RFE model, and then RFE will try to eliminate each of the feature, and then depending on the performance, it will decide which feature can be eliminated in the first round. So we end up with n minus one feature, and then we do the second round of the RFE. So in the second round, we are going to try to drop one more feature, and actually we are going to try to drop all the features each once, and then depending on the performance of the result, we are going to drop the least important second feature. Okay, so this is the process of the RFE. And then we also have to create a model again. So we can use the same data set and we use the same logistic regression model. And then we do the RFE, and then we send the logistic regression model, and then we specify that we only want to keep 4 features. And after that, we train that again, and then we can say we can print eventually we are going to only keep 4 features, and then those are the support and the ranking. So for the support, it will give you a bunch of the trues and the falses, and remember there are only 4 features we are keeping, so there will be 4 trues. And then for the ranking, so for the ranking, well, the 4 ones are the ones we are going to keep, and then number 5 will be the first feature got dropped, and then number 4 is the second feature dropped, and then number 3, number 2, and eventually we are gonna leave 4 ones, and those 4 ones will be the features we are keeping. Okay, so to make it easier to see, and we are zipping the feature names and then the rankings, and then we see, okay, the 4 features more important features are the mass, PADI, PLES, and PREG. Okay, so the next thing, let's put those 2 feature selections together. So for the RFE, those are the 4 features we got, and then for the select k-best, those are the features we got. So, well, the problem is they are not quite the same, right? So let's just use the 4 features RFE recommended for us, and then we do a transform. So we can use the fit RFE and then do a transform of the data, and then we only have 4 columns here, and we use those 4 columns to do a train test split, and we use the logistic regression, and then let's check the confusion matrix. So if I remember correctly, this confusion matrix is slightly better than this one. So, okay, the point is, well, why do we have different top 4 features from RFE and the select k-best? So think about that. So RFE, it recommends us different 4 features compared with the select k-best. So why they're different? And if we have to make the decision, which one are we going to trust? Okay, here's my answer. So for the select k-best, well, we consider that as a static feature evaluation. So when we do the select best, we didn't say which machine learning model are we going to use, right? And then, well, it doesn't run any machine learning algorithm to select the k-best features. Okay, and how about RFE? For the RFE, we have to give it a machine learning model. And for example, if we have decided that we want to use logistic regression, and then what? And we just go ahead and then make a machine learning model and send it to RFE. So RFE is evaluating the features, or evaluating the feature importance using a specific machine learning model. So if you have already decided that logistic regression is the right machine learning model you're going to use, so go ahead and then send the logistic regression model to the RFE and then have the RFE help you evaluate the features. On the other side, if you haven't decided which machine learning model are you going to use, however, you want to have some sense on what are the good features, and then go ahead and use the select K best. Okay, so the next part, we have a fun test. So what we are trying to do is we want to introduce a noise dataset. We are still using the diabetes data, and then those are the feature names, and we are adding one more feature, and that is just nothing but random values between 0 and 100. Okay, so we add a noise called noise column, and then we just give that a bunch of random values. And after that, let's try to do a feature evaluation. So why do I do that? Well, since this is a noise feature, and this feature doesn't help us to make any of the predictions. So, in our feature evaluation, it is supposed to be a bad feature, right? So let's try that and see if our feature selection really shows that that is a bad feature. Well, depending on how lucky you are, and usually I tried it several times, and usually the noise is not it's a feature we are going to throw away. But if you are lucky enough and you have the noise as one of the ones, and then we have a funny condition. We introduce a noise feature, and then actually it is evaluated as an important feature. So go ahead and write this code by yourself, and I suggest you pause this video a little bit because I'm about to show the answers. Okay, so go ahead, pause the video, and then do the coding by yourself first. Okay, so this is my answer. Well, I know I want to generate the random values between 0 and 100, and then I know there are a total of 768 records. So I'm gonna just create a column with random values from 0 to 100, and then the length of this column will be 768. Okay, and then after that I just add that column into the dataset. So now I have this dataset updated. And for the parameter names, and remember I'm adding one more feature name, so that is noise, right? And then I want to do a train test split. I want to separate the features and the columns. The column we are going to predict. And after that, we do the select k-best. And then, in the select k-best, where is my noise? So my noise is here. So that is indeed a very small value, and it is even a little bit higher than Paddy and very close to press. Okay, so even this is just a random value feature. It's surprisingly not the worst feature in this case. And then I also tried the RFE, and in RFE my noise is on number 4. So it is bad, but yet, it is better than skin or test. Okay, so this is my observation. Even though I introduce a feature with nothing but random value, and sometimes it is not the worst feature. And I have seen people doing some weird tests, like when they add a little bit noise to an existing feature, or they just add a new feature with pure noise, and then it can drastically change the performance of a machine learning model, and that is possible. And that is another point that we should do feature engineering, because if there are noise features, then they won't help us do any prediction, but they will further damage the performance. So we should do the feature engineering and get rid of them if we can. Okay, so that's it for this video, and I have probably 1 or 2 videos next. Okay.